Okay, welcome everybody. This is Mac, and we're going to talk about number classification. I have an entire flowchart as a study guide for you to refer to and study back to. If you have that printed out handy while we do the sheet, that could be helpful to you. And if you haven't watched the video, go watch it. If you don't know what I'm talking about and you just stumbled across this video on YouTube, I do have a website, maxtutorials.com. I'd like to drive you there to take a look, and it'll really help you to get a lot of help here with your math, okay? So in number classification, just to remind you of some things. First of all real numbers, that's all we're going to deal with. The only time a number is not real that we know of is when we have, I'll just give an example, a zero on the bottom. If you have a zero on the bottom, this is not a real number, okay? Or if you have a square root of a negative number. That is not a real number. So as long as we don't have these situations, they're real, okay? Every number is going to be rational with one exception. Sorry, there's my pen. There we go. Sorry. Every number is going to be rational. The only way that something is irrational is if it doesn't stop and it doesn't repeat. So for example, pi is the most famous one. Okay, 3.141, and all these kind of numbers that come after it. And it never has a pattern to it. That's one example. Another one is when you take a square root of any number that's not a perfect square, any of these. Now, if you do this, well, if you take a look at that, that can equal 6. So that would not be an example of an irrational number. Okay, but if you take the square root of a number that's not a perfect square, that would also be an irrational number. Plug it in a calculator to see what happens. It'll take up every space. Doesn't matter how many spaces you have, it'll go on forever and it'll never repeat. Okay, so that would be an irrational number. When I say rational number, that's any number that's not irrational, okay? And that includes repeating numbers. So 3.333, that's rational. Okay, so as long as it has a pattern to it, or if it's, 1 point, let's just go actually 0.12122. Do you see a pattern? I see a pattern. These would be considered rational numbers, as weird as that is, okay? So the only time it's irrational is if there's no pattern or a repeat to it, okay? An integer is just a non-decimal. Okay, and I know I went over this on the video, but just to do it right here. Natural and whole numbers are pretty much the same. These are just going to be positive numbers. The only difference is whole includes 0, while natural doesn't include 0. Okay, so let's go through these. Number 1, this is a rational. It's an integer. Integers can be positive or negative numbers that don't have decimals. This is a natural number. It's also a whole number, right? So that's number 7. Number 13, this is a rational number. This is an integer. This is a natural number, and it's also a whole number. Let's take a look at number 5 here, -5/2. Well, that can be written as a fraction. It's not repeating. So this one right here is going to be considered a rational. But that's it. For it to be anything else, it has to not be a decimal. Well, if you go 5 divided by 2, you're going to get some kind of a decimal, okay? So it's not any of the others. 0.333, hey, there's a pattern. That's rational, but it's not anything else because it's a decimal. Number 9 is square root of 2. If you plug that in your calculator, that'll go on forever. That would be an irrational number. Number 9 is -9, okay? So first of all, it is a rational number. It is an integer, okay? Because an integer is anything that doesn't have a decimal, positive or negative. To be natural or whole, it has to be positive. So we're going to stop here at integer. Square root, that must be irrational. Nope, because what's the square root of 49? It's 7, okay? So once I do that, that's rational. It's also an integer. It's also a whole number, and it's also a natural number. Okay, so it's all of those. Let's go on over here to number 2. -12 is rational, okay? And it's also going to be an integer. It's not going to be whole or natural because it's negative. 4, now that's going to be a fraction. So it's going to be rational, and that's it. It can't be an integer, whole, or anything else because it's a fraction. 6, 2.75. It's a decimal, so it's only going to be rational, nothing else. 18, square root of 16. Well, that's just going to be 4. Well, if that's the case, that's going to be rational. It's going to be an integer. It's going to be natural. And it's going to be whole. Okay? Pi, that's going to be irrational, and that's it. 14, okay, once I get this, it's going to be rational. It's going to be an integer. It's going to be natural. And it's going to be whole. Okay, and negative 0.8. Okay, so this one's going to be rational, and that's it, because it's a decimal, so it can't be an integer or anything else. Okay, so there's one example of how to classify numbers. If you feel good about it, go on to the next section. If you feel like you're still a little fuzzy, I'll see you in version 2. Take care.